Hey everybody, this is Larry. I'm doing this problem as part of a contest, so you're gonna watch me live as I go through my dots as I'm coding. There'll be an explanation near the end, and for more context, there'll be a link below on the actual screencast of the contest. How did you do? Let me know how you do. Hit the like button, hit the subscribe button, and here we go. Q2. Check if a string contains all binary codes of size k. So this is Q2 of the contest. Um, Here I pretty much knew what I wanted to do exactly because it just seems like a very straightforward sliding window because you're literally giving the window k a substring of k and then just keep on sliding that k and then see if you could see every possible number, right? Or every possible binary string. And so here I did a little bit of a bit mask trick where I declare a bit mask where I use so basically what that does, that code does, is give you a one string of size k. Also, it's going to be in the explanation, so don't worry, it'll be gone over. But once you do that, basically everything else is just shift left, or sorry, you move your pointers to the right, which means that you minus the bit on the left, and then you add the bit to the right, and then what I did was I put that number that you get in between, you put in a set, and if at the end you have every number or every possible binary string, if and there are only two to the k power of them, right? So once you check that as being your set size, then that's pretty much how you would solve this problem. So I knew how to do that immediately, and that's basically what I end up doing um, here. Pretty quickly, actually. I think I really should have been able to submit pretty much now. But see if you could spot the mistake real quick. I had it off by one, so there's that mistake. I knew that. I was like, oh, yeah, well, I was like, I gave it a quick thought of like, okay, for k is equal to 2, is it 4 or 3? It's 4, right? So that's what I did. And I still get 0. So this part is the little part that I would have been really ready to submit, and it would have been quick. But I print S, S is no good. Why? Why? Uh, and then and I wasn't sure. I looked at the code. Everything seems okay. And I actually have this blind spot where variable names, I just keep, as long as it's self-consistent, it's okay. I print stuff here. It didn't print, so I didn't even get executed once. Try again. Put it in the main loop. Just a print. Still no printing. So then that's when I realized, oh, I'm probably doing something really stupid. Yeah, and I saw that. I was like, okay, well, I just have to fix this. Okay, Q2. Check if a string contains a binary code of size k. Given a binary string s and k, oh yeah, so this one was just a rolling window. I actually took a little bit longer on this one because I was stupid. Um, Basically, s is the input string, and I also used s as a variable, not paying attention. And I was just like, why is it not running? And that took me a minute because, you know. Um, but basically, the idea here is that given a string, given any string, and any k, in this case, k is equal to 2, we just look at them one at a time. And then, and the way that I did it is I used bit mask to, and keep track of the binary number because k is only up to 20, so it could be only a little bit over a million, which will fit in an int is the key point there. But given that you have a string and you're doing a rolling window, so basically we just here we're like, okay, this is 00, that's we convert it to binary and then put it in a set. Here 01, put in a set. 11, put in a set, so forth all the way. And once you get to the end, if you have all 2 to the k numbers in the set, then that means you're good. So that's basically my algorithm. It's just rolling windows one at a time. And I added this if statement so that we only check to add in if we have enough digits. Otherwise, it's not really, it's only partial digits. And the other thing that I do is that I do current n is equal to mask. And this bit mask, just basically what happens is that let's say k is equal to 3, right? So this bit mask um, just gets you ones that are that length. So this is my binary bit mask, and what that does is that it just looks at the last k bits. So here, it basically enforces that we only care about the last k bits, and then after we do that, we could add current, and then we keep going until we could check whether it is 2 to the k number of strings or substrings. So yeah, so that, and the only reason why it took so long was because I reused the same variable and it didn't complete. So that was a little sad, but overall, pretty straightforward problem, pretty practice problem, and because this is O of n and this is O of n, everything here is O of, so this is O of n, this is O of, and everything else is O of 1. So this is O of n complexity. In terms of space, it will take 2 to the k space max, which is up to 1,000,000 in this case. And that would be okay because it's only up to 1,000,000 elements. And the reason why it's only up to 2 to the k is because by pigeonhole principle, basically, even if you have more than 2 to the k numbers, then that means that they'll get duplicate anyway. So yeah, cool. So that's Q2.